This is section 4.5, solving multi-step equations. Okay, so again, we're going to be doing equations like we've been doing this chapter. This time they're just going to be a little bit longer equations where we have to do more than just one step. Okay, to do these, what you can think of it like as it's like doing the order of operations or the PEMDAS stuff backwards. Okay, so instead of starting with parentheses, exponents, multiply, divide, add, subtract, we actually start with the add, subtract, and work ourselves in the other direction. Okay, so it's basically the opposite of order of operations. So if we look at the first one here, we've got x over 6 minus 4 is equal to 2. Okay, so again, like our equations we've done before, our goal is to get the x by itself and figure out what number it's equal to. So what I'm going to do is I'm going to split my equation down the middle through the equal sign. And I'm going to do my order of operations backwards, so I'm going to start with add, subtract. So if I look here, I've got to subtract by 4, so I want to do the opposite of subtracting 4, which would be adding 4. So I'm going to add 4 to both sides of my equation here, because when I take a subtract 4 and an add 4 and add those together, they go away from each other because they make 0. So on this left side here, I'm just left with x over 6 is equal to, and then on my right side, I'm going to take 2 and add 4 to that, which would be 6. Now I took care of all my add subtracts. Now I go to multiply, divide, so I've got a division here. So to get rid of dividing by 6, I need to multiply both sides by 6. Oops. Because then those 6's are going to go away, and I'll just have x is equal to, and then if I take 6 times 6, that comes out to be 36 for my answer. Okay, and just like we've done before in the past, you can take whatever your value is you get for the variable, plug it back in for the variable in the original problem, and both sides should equal. So like if we took 36 and put it in for the x, so 36 over 6 minus 4 is equal to 2. Well, here I would do 36 divided by 6, which is 6, minus 4 is equal to 2, 6 minus 4 is 2, 2 is equal to 2, and it checks out. Okay, let's try another one here. So this one we've got 3m plus 12 is equal to 27. Okay, so again I want to work my order of operations backwards, so I'm going to start with my add subtract. So to get rid of adding 12, I'm going to subtract 12 from each side of the equal sign, because if I do 12 minus 12, that's going to go away, and I'll be left with 3m is equal to, and then if I do 27 minus 12, I get 15, and then my last step here, I took care of my add subtract, so now I have to do my multiply divide. So here I've got 3 times m. To get rid of multiplying, I need to divide by 3 on each side. So then those will go away, and I'll have m is equal to, and then if I do 15 divided by 3, I should get 5. Then again, you could plug that back in there. 3 times 5, 15, plus 12 should give you your 27. Now this last one here is a little bit tricky, being that you can't necessarily work order of operations backwards this time, in the sense that you've got like a plus there. The reason that is it's just like the big division problems we've had before, where we treat it as 2 separate chunks, where the top part's a chunk and the bottom part's a chunk, and I sometimes put them in parentheses. It's the same type of deal here. So if you see a big fraction like this, you're actually going to want to get rid of that bottom division first, and then worry about what's on the top. Okay, so these ones are a little bit different than reverse order of operations. Technically it is reverse order of operations because this top part is like a parentheses group, but that can get kind of confusing sometimes. So the first thing I'm going to want to do on this one is I'm going to want to get rid of dividing by 15. So to get rid of dividing by 15, I'm going to take and I'm going to multiply both sides by 15. Because now if I multiply by 15 here, that's going to go away and that's going to go away. Okay, I can only do the division or multiplication first if this part's in parentheses or if it's a big fraction like that. Okay, then I'm going to take 15 times negative 6.2, which I'm going to have to use my calculator. 15 times negative 6.2, which is negative 93. is equal to, and then now I'm going to drop that parentheses group down. So 3 plus n like that. Okay, so now to get rid of that 3, I'm going to want to subtract 3 from both sides. Because then 3 minus 3 is 0, so that's going to go away, and I'll have n is equal to, and then if I do negative 93 minus 3, that would come out to be negative 96. Okay, and if you want to check it, you could take and plug back in, and you should get the same exact answer. Alright, look at the next ones here. Alright, so it looks like you guys are going to try some out on page 166, A through C. Then I'll get you the answers here. The only one I would be cautious on is C, because that's really similar to the one that we just did, where you want to get rid of your dividing by 7 first, and then worry about your adding 4. Okay, so just be careful on that one there. So for A, you should get V is equal to 12. For B, you should get A is equal to 65.6. And for C, you should get B is equal to 38. So hopefully you got those. Alright, we'll try out another one here. So this one is a story problem. So it says, in a city, the tallest building is 1,268 feet tall. It is 35 feet greater than 3 times the height of the 5th tallest building. How tall is the 5th tallest building? Okay, so let's focus on what our total is first. So our total here is going to be the tallest building. Okay, so the tallest building is 1,268 feet. So I'm going to put that off to the side with my equals, because I know that's my total I'm looking for. And then I've got the 5th tallest building is if I take 3 times the 5th tallest building and then put 35 with that, or 35 feet greater, I get this total number here. So what I'm going to do is I'm going to take my 5th tallest building and I'm going to make that a variable like an x. I'm going to take 3 times that variable, so 3 times x, because it's 3 times the 5th tallest building, and that's our x. And then I also want 35 foot greater than that. So if I'm doing greater, that would be like addition. So if I take 3 times whatever my 5th tallest building's height is, and then add 35 to that, that should give me my tallest building. So that's the equation set up. Then from there, what I want to do is I want to solve this out. So again, working my order of operations backwards, I'm going to start with my adding 35. So I'm going to subtract 35 from each side. So then I'll have that going away, and I'll have 3x is equal to, and then if I do 1,268 minus 35, I should get 1,233. And then my next step there, to get rid of multiplying by 3, I need to divide by 3 on each side. So then the 3's will go away, and it'll be x is equal to, and if I take that value, 1,233, and divide it by 3, I should get 411 feet. So the 5th tallest building is 411 foot tall. Alright, next thing here. Alright, they get into consecutive integers and consecutive even and odd integers. Integers are basically your positive and negative versions of just regular numbers. So like 1, 2, 3, 4, 5. You're not going to have any decimals, and you're not going to have any fractions. And then the thing with integers is it can be 0, and it can also be the negatives. So like positive, well, I'll just write some down. So like our integers would be like -2, -1, 0, 1, 2, and so on, okay? So on in both directions. Those are our integers. So if we're talking about consecutive integers, that's basically numbers in counting order, okay? So an example of consecutive integers would be like 3, 4, 5. Okay, that would be 3 consecutive integers because they're back-to-back integers. Okay, another example would just be like some of these up here. So like -2, -1, 0. Those would also be a set of consecutive integers. Now we're going to get into consecutive even integers. So it says that is beginning with an even integer and then counting by 2. So an even integer would be like 2, 4, 6, 8, that kind of thing. Also the negative versions of that. And then if we go up by 2, that would get us to the next even integer. So like say we started at, I don't know, negative 6. So 6 is even, so negative 6. Oops, I'm writing it on the wrong one. 6 is even, so negative 6 is also even. So if I want to go to the next even, that would be negative 4, because I'm adding 2 to that. So if I add another 2 to that, that would be negative 2. Add 2 to that, that would be 0. Add 2, 2, and so on. Okay, so those would be our consecutive even integers, because they'd be even integers that are back to back. Now our odds are basically the same thing, except for we start with an odd integer and then we go up by 2. So like say we started with like negative 5. So negative 5 would be an odd integer. Then if we go to the next one, if we add 2 to that, that would be negative 3, negative 1. We skip 0 because that's only 1 away from negative 1, and we go to a positive 1. And then the next one there would be 3, 5, 7, and so on. Okay, so what they want us to do for these next examples here is they want us to find consecutive integers, and then they have to meet a certain thing. Okay, so this one says find 4 consecutive integers, and they got to be odd, whose sum is negative 8. Okay, so if we think about sum, that means add. So we want 4 consecutive odd numbers that add to be a negative 8. My first thought there is, well, I've got to have negative numbers if I'm going to try to add to a negative 8. So maybe I start with like negative 7, negative 5, negative 3, negative 1. So if I start with those numbers, that would be a negative 12, plus negative 3 would be negative 15, plus negative 1 would be negative 16, so I'm too far off on that one. So I got to try something else. So if I'm at negative 16, to get a sum of negative 8, I got to think a little bit bigger here. So maybe I ditch the negative 7 and go to my next one here that would be past negative 1, which would be 1. So if I add these guys together, negative 5 plus negative 3 is negative 8. Plus a negative 1 would be negative 9, plus a positive 1 would get me back to negative 8. So if I added negative 5, negative 3, negative 1, and a positive 1, I get negative 8. So those would be my 4 consecutive odd integers that add up to be 8, or negative 8. Okay, so basically what I do is I just guess and check till I get something that works. Same thing with this next one here. So we're supposed to find 3 consecutive integers whose sum is 27. So this time we only want 3, and we want just consecutive integers, so like 1, 2, 3, not just odds or evens. We want them in order, and we want them to add to 27. So if I think about it, like my first set of 3 consecutive integers, and I'm going to try positives because it's a bigger number there, would be like 1, 2, and 3. Well, I know that's not close at all, because if I do 1 and 2, that's 3, plus a 3, that's 6. I'm nowhere near 27. So I got to jump up to bigger numbers here. So maybe I try like 4, 5, 6. So if I add 4 and 5, that's 9, plus 6 is 15. So I'm getting closer, but I'm not quite there yet. So those don't work, those don't work. Maybe I go 6, 7, 8. So if I do 6 and 7, that's 13, plus 8 would be 21, so I'm still not there yet. Maybe I jump up a little bit more here. Maybe I go 8, 9, and 10. Okay, so if I do 8 and 9, that's 17, plus 10 is 27, so that would work. So if I did 8 plus 9 plus 10, that comes out to be 27, so those would be 3 consecutive integers that add up to be 27. So with those types of ones, I just do guessing and checking and try to work my way to the answer. If it's in the negatives, I would start with negative numbers. If it's in the positive, I would start with positive numbers. You might have to do a combination of both, like this one here where we had some negatives, some positives. So like I said, just guess and check till you kind of come up with something. Alright, so that's it for notes. So your book page is page 169, 14 to 32 even.